The ability of gCADPlus to fly to a particular Google Earth location, which is reached by gCADPlus, and insert Google Maps image, can be quite useful when you want a base plan to take to a site. Here's an example from Western Australia, and the site here is rather densely covered with vegetation, so it's a little difficult to see through the trees and see what shapes we have and so on. But I have been able to use the line command and trace approximately the boundaries. What I'm aiming to do here is to produce a drawing that you can plot out as a little mud map and put some dimensions on things and mark important detail. And one of the trickier things to measure is, say, a kidney-shaped swimming pool. So what I've done here is use the Polyline command and gently traced around that organic shape, that kidney shape. So that's draw Polyline, and I'll just go round on the outside of it like so. So I simply traced around the polyline and then used curve fitting over here, fit smooth. I changed from lines and arcs to a quadratic B-spline, and that gives you the ability to tweak the line and fit whatever shape it is that you're trying to match. Let's remove that. So we now have three lines approximating the boundary and the border of the pool. What we don't have is a sense of size, but in Google Earth puts a little scale on, and this scale here is a 10-meter scale. So let me just move. What I've done is drawn over the top, so I'll move the line and the piece of text that I've added. So that's what you see in Google Earth. There's a 10-meter scale. So if we select the line which I drew over the top of the scale, we can check its length. So its length is 10 meters. So what I've done is scale up the drawing to match the size. So what I'll now do is insert another copy of this image and run through how I went about doing that. So it's draw, raster image, the close-up of the pool and the site. We'll pick this one, so we'll insert it, and in it goes. So I popped it in like so. Now, if we drew a line from there to there, you see we get 3.22. So what we do is scale this image appropriately, and that's what I've done over here. So it's just a matter of, let me erase that. It's just a matter of doing the mathematics to scale the image up. You scale the image and everything that you traced over the top, and that's best done by tools and selection and select all. So I'll do that. So now I've selected everything in the drawing, which is the boundaries and the kidney shape pool and the image itself and our line representing 10. Now in the building trade we work in millimeters in many countries, and we've set this at meters. So I've just scaled by a factor to get this accurate. So now when we make an inquiry of the drawing, it's spitting back numbers to us in meters. What we want to do is to scale. So I right click and pick scale. As a base point, I'm always in the habit of typing 0, 0 and hitting the enter key, and I now ask for a scale factor. So I'll type 1000 and everything disappears. Right click, zoom extends. So now our line, which is supposed to represent 10 meters, if we pick it now, that line should be 10 meters in length in millimeters. So it's 10,999,658. So we've scaled this drawing up such that now it measures, everything in it measures millimeters. So if we say, what's the length of that pool from, say, there down to there, you can see it's about 7.8 meters in length over that distance. You can also do things like, now we know the area of that pool is, it's 31. Actually, it will be, you need to turn it to get a correct area measurement. You'll have to turn it back to the lines and arcs, but I digress. So we now have a base map that we can work with. At this point, you might want to remove the image. Let's just see. So we select it and erase it. So now we're left with our drawing. I'll just undo that for the moment, because what I would like to do is just square things up to make drafting a little easier. You see this, what I've done over here is pick that line, I've drawn a line along that E, which is probably a more accurate reflection of the back boundary. So if I pick that one there, it's 168.38. This one is 166.29. So a rotation angle somewhere between 167. So if we took 180 and took 167 away from it, we get 13. So if we now erase the image, here's our, and I'll get rid of that. I really don't need this scale bar anymore. What we're trying to do is just do a mud map. So what we're after now is to pick, in fact I'll do it the same way, tools, select all, and right click. This time we're going to rotate around 0, 0, hit enter, and our rotation angle will be 13 degrees plus. And now we're pretty much squared up, although you can argue that we're not quite there yet. This line I'd prefer to be 90 degrees, so let's make it so you can change angles like so. And this line here I would prefer to be at 180. Remember, these measurements have all come off Google Earth, and this line here might well be at an angle running down that side boundary. If you zoom in here, we'll go modify and trim. This can be the cutting edge, right click, pick the overhanging bit, right click to repeat the trim, make that the cutting edge, zoom in with the wheel of your mouse and just slice off that little bit if you can. And notice that as we zoom in, the lines don't meet, so it's modify, extend to that as the boundary, right click, pick that line to extend, now modify, trim, this can be the cutting edge, right click and knock off that little piece. So let's right click and zoom extents. We've now got a layout for the drawing, and what we now want to do is to much more accurately, we've got the kidney shaped pool. Now we need to accurately place the house footprint, and you would run around that measuring the house and getting some dimensions. If you could, it's a good idea to triangulate so that you measure things accurately. So I would say draw line. Let's imagine, I need to refresh my memory at the moment as to what that house footprint looks like. So what I'm going to do is to insert that raster image again. So I'll insert it and pop it over here. And yeah, that it's quite a difficult house for me to recognize. The main part of the building is there. Remember, we've rotated things to square things up, and so we now got a boundary there. What we need to find is some points to give us reference. If you could pick up that corner there, let me just draw a line. I'll put a point in, draw a point. You could pick up that point there, so, and then measure the distance from that point there across to there, and then back to another point on the building, which might be this point here. You can triangulate from those 2 points up to the back corner, hopefully, and then from those 2 points you could pick up this point here. You could measure from that point to the corner, that point to the corner. That would help you locate the house. The other alternative way is just to use ortho on and run around the edge of the house. It's a little difficult to do just from a Google Earth image. The whole point of the story is we now have a rough plan for this site, and we've got a rough idea of the kidney-shaped pool location. There's clearly a whole lot of paving within here, and would now want to locate that paving accurately. So let's, for the sake of argument, say the paving ends at some point there. You would then be able to measure from the end of that paving across to this corner, and from the end of that paving there across to that corner, and that would, and if you had another set out point, say somewhere here, measure there to there, you could use the resultant triangles to accurately place the back boundary. As I said, a little difficult to do from an overhead Google view, but certainly the Google Earth image, cutting it into a drawing, can give you a reasonable base plan to work with. Let's erase that again. We'll leave those point markers in there. Right click and zoom extents and regen. Right click and zoom extents again. Now we're seeing pretty much the whole drawing. I'll eliminate those point markers because they're causing some degree of difficulty. So what we're after then is to build our drawing. Once we've built our drawing, we format layouts, start a brand new layout. If you routinely presented your drawings on A2 sheets in album format, we can do that. Now in layout, we see our design. You might want to do that in portrait. So format, layout, a new one with an A2 sheet in portrait view, and layout 2, let's zoom extends as what we want. So there's our layout developing. To present this to a client, you would insert into here your title block information, and you can scale within that frame. When I click on the edge of the frame, it jumps into presentation space, so I can move things around, tighten things up if I need to, right click and display on the layout, then deactivate the layout. I could make the frame, the color of the frame, I can make the color of the frame 255 and then unselect all, and now you just see the sheet of paper, the A2 sheet of paper with the boundary on it. It's now just a matter of inserting some symbols. You could go to the library, pick plants, pick standard, and just scroll through here and find the symbol that appeals to you. You might find in a case like this where there's a substantial lot of planting already in existence, it might be worth going to the library and broad scale and picking, say, a new large shrub or a new small shrub, existing trees to retain, and we'll insert that one into the drawing and pop it down. And once we get it in, we can copy it. So we're copying, copy there. So now we're just mapping, if you like, the trees across the back using these sort of fairly standard symbols. There are various ways of labeling those symbols and generating a plant schedule, but that's probably enough for the moment. We mentioned in the layout space that you just need to add your logo and then some sort of information about the client, location of the drawing and so on. What I'll do here is just pick that up and edit that text because it's 2015 now, and in it goes, and right click and extends. So that's just a small indication of how you might use Google Earth as an aid to site assessment.